So this is section 6.5, which is graphs of polar equations. We're going to talk about polar curves and parametric curves, symmetry, analyzing polar curves, rose curves, limicon curves, and other polar curves. So we have three types of symmetry when we're talking about polar equations. So we have x-axis, so that's this one right here. So you can see reflected over the x-axis or the polar axis. And then we have y-axis, which is also the theta equals pi over 2 as a line of symmetry. And then we have symmetry about the origin or the pole. So those are our three different types of symmetry that we could possibly have. So the way that you're going to test for symmetry is replacing your r and theta by some combination of a negative r value or a negative theta value or both. So here's our example. It says use the symmetry test to prove that the graph of r equals 2 sine of 2 theta is symmetric about the y-axis. Okay, so we have r equals 2 sine of 2 theta. So it says that we're testing to see if it has symmetry about the y-axis, which means we would replace r and theta with negative r and negative theta. So this is going to become negative r equals 2 sine of 2 times negative theta. So then just distributive property here, we're going to write this as 2 sine of negative 2 theta. Okay, and then if you think back to our identities that we did, we have the even and odd identity. So even and odd identity says that sine of negative u equals negative sine of u. So that means that in this case, this would be negative r equals negative 2 sine of 2 theta. So then we have a negative on both sides, so we could divide both sides by negative 1, and we end up with r equals 2 sine of 2 theta. So we showed that it is equal to the equivalent, therefore it has symmetry about the y-axis. Okay, so the rest of this lesson is just kind of showing you different, I guess that we have one other example that we'll go through, but showing you different graphs, and you don't have to graph any of these by hand. This is all stuff you can do on Desmos. So kind of just exposing you to different types of graphs. So we have rose curves. So if we wanted to graph rose curves, so again, I have my settings set to polar coordinates. So I could graph r equals 2 cosine of 2 theta. And you can see, so this says that if n is even, then there's 2 n petals. So I put 2 in there, so you can see there's 4 petals. If n is odd, then there is n petals. So I put a 3 in there, and you can see there's 3 petals. So that is rose curves. This is limicon curves, and these, same idea. So we can type in, if I go back here, so r equals, let's say, 3 plus 2 sine of theta. Okay, and you can kind of play around with different values. And then if I change this to cosine, you can see it's the orientation of the graph changes. Okay, so we're going to do an example with that. So this says, show that the graphs of r1 equals 4 plus 3 cosine of theta and r2 equals negative 4 plus 3 cosine of theta are the same dimpled limicon. So we are going to type in, again, you're not doing this by hand, you're just typing this into Desmos, 3 cosine of theta, and then we can type in r equals negative 4 plus 3 cosine of theta. And you can see, you can turn one graph on, they're the same graph. So again, I'm just gonna put desmos in here. Okay, so use desmos to verify that these are the same. Okay, then we have the spiral of Archimedes. So spiral of Archimedes is R equals theta. So you can see that's kind of cool. Okay, and finally we have the lemniscate curves. Not sure if I'm saying that right. So that one, because we have to put it in as a linear, so it can't put r squared in, so we could put r equals the square root, though, of, let's say, a is 3, let's do 9 sine of 2, of 2 theta. Okay, so that kind of shows you that one. This graph right here is the cosine one, so have an example of each of those. So again, this lesson is just to kind of get you familiar with different possibilities of polar equations and their graphs. We're not going super in depth to the process of graphing these or anything like that. So if you have any questions, let me know.